Alright, so the next tutorial video I want to talk about is classification of matter. And I just want to make sure that we understand certain terms that we will be using when we're talking about, now that we're talking about equations and balancing equations and formulas and things like that. There's just some terms I want to make sure that we understand what's what. So in the classification of matter, of course we have everything that has mass and takes up space is matter. And then we look at can it be separated, physically separated. If the answer is no, then that lets us know that this must be a pure substance. Must be a pure substance. It means it's all the same thing. If we were to say yes, it can be separated, then that would lead us to the fact that this is a mixture. More than one thing put together, but not bonded together. Pure substances, we could go on and ask the question, can it decompose? Can it chemically decompose, come apart? For a mixture, we would ask, is the composition uniform? Okay, so I'm going to go on the next slide and we're going to answer these two questions here. So again, we had pure substance and we asked the question, can it chemically decompose? Alright, if my answer is yes, then I have a compound. If my answer is no, then I have an element. Okay, element, remember the definition we learned for element, it is made up of all the same atoms. Can't be broken down further. Okay, a compound, its definition is two or more atoms or elements bonded together. Okay, now we also then have what's called a molecule. Okay, the difference between a molecule and a compound is a molecule is two or more of the same element. For example, H2. We call that a molecule of H2, not the compound H2. An example of a compound would be water, H2O. I have two or more different elements stuck together. Okay? When I have just the same two elements stuck together, like H2 or O2 or N2, that's what we call a molecule of those things. Okay? And a molecular formula is the actual number of atoms in a compound. Actual number of atoms of each element in a compound is what we call a molecular formula. Okay, if we go to the next slide, we can answer about mixtures. So we have mixtures, and we have to ask ourselves, is its composition uniform? Okay, if we answered yes, it is, then we have what's known as a homogeneous mixture, where everything is the same throughout. There are no differences. You can't see any differences in it. If the answer is no, then we say that it is a heterogeneous mixture. Heterogeneous mixture, meaning you can see different parts to it. It has different parts. A good example of a heterogeneous mixture would be salad dressing. You can see the different parts in the salad dressing. Example of a homogeneous mixture, Kool-Aid. When you get the Kool-Aid mixed up properly, you can't tell where the Kool-Aid mixture is and where the water is. There's no distinction. It looks all the same throughout. Okay, so those are just some definitions that you need to know. When we talk about compounds, you need to know what we mean. When we talk about elements or molecules or mixtures, you need to know what those terms mean. So I hope this helps clear up any confusion we had about those terms. And for your assignment, I want you to give me an example of the following, and not the examples used in this presentation. You have to come up with your own example. So I want an example of a homogeneous mixture, a heterogeneous mixture, a compound, a element, and a molecule. Okay. Now, you can, if you listen carefully, you can use any examples that I might have said in the video, but any ones that I wrote down on the whiteboard, or on the blackboard, I guess you'd say, you cannot use those as your examples. Okay? So you need to come up with other examples for heterogeneous mixture, homogeneous mixture, compound, element, and molecule. All right. Thank you very much.